All right. Hello, everybody, and welcome to my first video on Wyzant. So I hope you enjoy it. Today we are looking at a trigonometry problem with a ladder leaning up against a wall. And the angle that ladder makes with the wall is 22 degrees. This top angle here is theta. And we're going to be referring back to theta a couple times through this video. So first, we're going to want to calculate our missing length L, or the distance that the bottom of the ladder is from the wall. And we can use this with sine theta. So we know that sine theta is equal to the opposite leg over the hypotenuse. So in this case, sine of 22 degrees initially, our initial angle, is equal to the opposite leg, our missing variable L, over 28 feet. So what we'll do is we will multiply both sides by the hypotenuse. We will cancel it out on the right side. And on the left side, we'll be left with 28 times sine of 22 equals L. Let's do that on our calculators really quick. 28 times sine of 22, and make sure your calculator is in degrees, not radians. And we get our length L to be around 10.489. And rounded to 3 significant figures. That's what I do because it's a habit in engineering. And so we will take that value and and we will use that for our second portion of the equation. So what they want is to add 2 feet further to our 10.489 value. So we're stretching out that ladder away from the wall just a little bit more, and they want to know how high the ladder is after we do that. And so what we will do is our same sine function here. We know that our opposite value is now 10.489 plus 2 more feet. And then our hypotenuse length, the ladder length, didn't change at all. We didn't open up the ladder any more than it was. And we want to do sine inverse of both sides of this equation. So when we do the sine inverse of both sides, we'll cancel out the sine on the left-hand side, and we will be left with theta equals the sine inverse of the opposite over the hypotenuse. So we're finding our new angle change that was created by moving that ladder. And that angle should open up a little bit more. And so we will do that on our calculators now. Sine inverse of 10.489 plus 2, all divided by 28. 10.489 plus 2, parentheses, divided by 28. And that's what it looks like on my calculator, so you can check my work. And we get that our new angle is around 26.489 degrees, or 26.49 if you want to round that last digit over. Okay, and so now the last thing that we have to do is calculate how high the ladder was before and subtract the new height that we calculate as well from that to get our delta L, or delta change in height. Okay, so what we will do is use our cosine function now, which we know cosine of our angle is equal to the adjacent, or in this case, the adjacent would be this vertical leg, our wall here, over the hypotenuse, which we know is the ladder, and that's 28 feet. All right, we will do cosine of our previous answer, the 26.489 degrees. We'll multiply that by 28. And so our new height for the ladder after we shifted it is about 25.06 feet. All right, and now we will do the same exact thing, but with the 22 degrees and not the 26 degrees. So we will do 28 times the cosine of 22 degrees, just like that. Because remember, we multiply both sides by our hypotenuse. It cancels out on the right-hand side, and we're left with the 28 times cosine theta equals our adjacent leg. So now we're solving for our old height with our original angle, and we get that to be about 25.961 feet. So now we want to know the change in height here. You could subtract it both ways. You could subtract the new answer from the old answer, or the old answer from the new answer. It'll just be a sign change. It'll be a positive or a negative value but what we're looking for is the absolute value of that. And that comes out to be 0.901 feet rounded. So, yeah, that is the video. I hope you enjoyed it, and you all have a great day.